My name is Dr. Jean-Pierre Lin. I'm a paediatric neurologist. I was trained in Scotland and then came to work in London, and I've been at Guy's and St Thomas's NHS Foundation Trust since 1996 as a consultant. I've worked with dystonia for approximately almost 30 years. It started off as a junior doctor, and even when I started doing my paediatric neurology, I was dealing with childhood dystonia cases, and so it's been a part of my training from very early on. I began doing research into movement disorders in childhood in 1990 for my PhD, typically looking at the motor disorders of cerebral palsy, of which dystonia is an important component. My clinical supervisor, Keith Brown, was very interested in the early onset of movements and movements and postures. And I've always had the sense that dystonia and the early movement repertoire of the young child and infant is a relevant starting point for all normal development, as well as the developmental disorder of dystonia. I've offered every type of treatment in my career. I think I was one of the first doctors to use botulinum toxin in children with dystonia in the UK. I've worked with intrathecal baclofen. I introduced the idea of using gabapentin for managing dystonias, particularly painful dystonias or very severe dystonias, and also using clonidine. Now, gabapentin and clonidine are completely different medications. They're completely different from trihexyphenidyl, which is an anticholinergic, and they're completely different from the GABAergic drugs such as baclofen and the benzodiazepines. So I think I've done what I could to use the spectrum of pharmacological management strategies. I've worked with allied health professionals, and we've done our very best to rescue whatever we can in terms of functional strategies for accomplishing certain tasks. But in the end, the one methodology that has really proven to be superior to all others is deep brain stimulation. So now the issue of the deep brain stimulation is exactly who can benefit. Of course, this is a loaded question, because a little benefit to somebody may be worth more than the same amount of benefit to somebody else. So it's very much in the eye of the beholder. Currently, the branching point in medical decision making is, can we satisfactorily help to manage children with acquired dystonias, and in particular with dystonic cerebral palsy? That is a question which we've been addressing over the last 10 or 15 years by thinking about the context of the life of the child living with dystonia. And by the time we were offering DBS 15 years ago, those children were in sort of over the age of 15 with multiple deformities. By the time you have a fixed deformity with a movement disorder on top, there are relatively limited benefits for neuromodulation. Now, apart from the visible deformities, there's another issue with growing up with a movement disorder, which is the lack of opportunity, the specialized education you may need, the difficulties with communication, and so on. So the accumulated disabilities or comorbidities that occur with a lifelong motor disorder at the time when the brain is supposed to be developing, you can see there's a multiplication of the impact of that dystonia on the child. So it's been an objective of us to see, well, if we can peel back to the point before these morbidities have become entrenched, is it possible for us to then chart out a better future pathway for the child than once everything that can possibly go wrong has gone wrong. So this is where you're trying to get the child as close to the time of onset of their dystonia to see whether a moderation of dystonia can then allow other functions to emerge. Now we now know, because of the ancillary data that we've gathered, that if we measure the integrity of the sensory system, if we measure the integrity of the motor system with neurophysiological tests, we find that children who have an abnormality in sensory processing or an abnormality in motor conduction, that these children do noticeably worse after deep brain stimulation. They don't do well, but they don't deteriorate, they just don't improve as much. And so we're now applying a selection process that's based on some clinical evaluations that we know can help us counsel families about which child is more likely to benefit. And it makes sense, because if you have a motor system that is not receiving sensory information, then the whole engineering of motor function is blind to the output. So you need to have an intact sensory system in order to have a functioning motor system. And it now, to me, seems more evident that motor difficulties can actually be, at least in part, explained in terms of sensory afferent abnormalities. So if the sensory pathways are in some way non-functioning, then the blur that is what is happening informs the motor system, and the motor system produces a blurred output, which is dystonia. So this is again another issue about, what is the cause of a motor difficulty? Is it actually a motor output problem, or is it a sensory filtering issue? There's going to be a mixture of the two. I think that if we look at the field of dystonia now, it's quite clear that there are an increasing number of distinct genetic syndromes that are emerging. And what's particularly interesting is that those genetic syndromes appear to be occurring much earlier on in life. So under the age of 10, under the age of 5, possibly around the age of 18 months to 2 years. As soon as you see that, you begin to be aware that if cerebral palsy occurs in the first 2 years of life, then a genetic expression of a movement disorder in the first 2 years of life could easily be mistaken for a cerebral palsy. So I think that in the future we will be able to diagnose very early onset movement disorders that have been previously referred to as cerebral palsy as just being early onset genetic disorders. Now, in that context, all the more important to have a strategy to help those children as soon as possible. And this is where early delivery of deep brain stimulation neuromodulation becomes important, because as I said in my talk earlier on, do we need to wait until they're 10, 15, 20 years old before we say, let's offer you deep brain stimulation? Because if we do it sooner, then maybe we can free up the child from all the comorbidities which will accumulate later on.